I want to tell you a story today. In fact, I'm going to tell you multiple stories. And I want to start with this looking down the river of time. But you don't know if that's a river. You think it's a river, but maybe it's a lake. Maybe it's just a big puddle of water. And why does that matter? Why does knowing the name of something matter? Because if this is a lake, it's different than if it's a river. If you're in the river, you can swim in it, you can paddle down it, you can watch people floating by with their margaritas. Or if it's a lake, you will think about maybe building a dam, or you think about these things differently. So a big point of my talk today is framing matters. The way we talk about things, the way we think about things, basically gives you the initial mental model, the way you think about things. So I'm going to start by telling you about me. So I am a cyber, tribal, techno-cognitive anthropologist. What that means is that I think about groups of people, both individual and in small groups, as they work, as they use these AI systems that we've built. So I've been doing this for a while now, and I'm also a software engineer, a research scientist, and university faculty. So I'm really interested in how different people in different settings use the AI systems that we've built, including things like Google, your favorite medical diagnosis system, whatever it is. The river of time will come through, and I'm going to start way back. This is my first year of grad school, and that's me without a beard. I think it's the only existing photo of me without a beard. The rest of my class all has beards, and so I finally figured it out. And that same year, you might remember, Time magazine put the PC, the personal computer, on the cover as the computer of the year. This is also the same year when CD-ROMs first became available widely. Only for music, mind you, not for memory. It took another year or two for them to figure out that you could get 300 megabytes of data on there, which is what, 10 pictures, right? But at the time, this is a major advance. So I want to cast your mind back to then, because that was the year that I was hired at Xerox PARC, this big research lab in California, which invented all kinds of stuff. But Xerox came to us and said, look, we have this giant printer / copier, and it's a mess. The UI looks like this. And the problem they were having was nobody could make it work. So they said, hey, you've got AI, don't you? We said, sure. What do you want? We want you to build an AI front end to this. Does this sound familiar? It should. We want you to build an AI front end to this so that people can use it. And we said, yeah, we know exactly how to do that. So I worked with Richard Fikes, who's one of the grandmasters of artificial intelligence planning. And he and I built an AI planning system based on theorem proving. That means we had a system where you would describe the goal to this thing. I want to make 24 double-sided copies with inserts, whatever. Describe it. And it would generate a plan, a provably correct plan. So none of this statistical stuff. We knew exactly that this sequence of action would achieve that goal. No question. We could prove it. So this is kind of a reconstruction of what the UI looked like. You would select a bunch of buttons up there, put in a few numbers, and hit go, create, and it would generate a sequence of steps for you to go through. For you, the human. Okay? So if you follow that sequence of steps, you will successfully achieve your plan. Awesome. Then Lucy Suchman, anybody know about Lucy Suchman's work? Okay, so she wrote a really important book, I'll get to in a second, and where she talked about the relationship between people and plans and how people understand action in particular situations. And so what we did was to basically say, hey, we should have a usability study. Has anybody heard of a usability study? Right, you all have. I hadn't at the time because I was a newly minted PhD AI software engineer. And I thought, usability study, sounds great. What do we do? And Lucy says, what we're going to do is we'll set up a task, a standard benchmark task for people to go through, and we'll put up a camera and we'll watch them use your software to achieve the task, right? And so we had people come through and they consistently failed at the test. What's wrong? I said to Lucy, you know, we need to get better teaching. Because obviously, these people just don't understand what's going on. And so what you see here in this sort of really low-res screen grab is Ron Kaplan and Alan Newell, who are arguably two of the smartest people on the planet. Alan Newell was friends with Herb Simon, and so they did a bunch of basic work in cognitive modeling. They failed. And I had this sudden realization that it wasn't them, it was me. You probably used that line before. But it really was not them. It was me as a terrible designer. And so Lucy wrote this book. Chapter 6 is basically Dan's failure to achieve a good user experience. And so this was profoundly motivating to me because I was a dyed-in-the-wool AI guy who knew that AI was going to take over the world, and I couldn't get my first system to really work well. And I thought, oh, maybe HCI is important. So I kind of became an HCI person at that point. But I never lost contact with AI. So the rest of my career was HCI plus AI, what we now call HAI. And so that was kind of a disaster, but there were more disasters to come. So fast forward to 2017, and you might have seen this Jibo social robot. Maybe you had. So it was introduced as a in-home effective device that you would bond with, you would grow to love. And so they introduced it in 2017, and in 2019, they discontinued it, just 2 years later. And when it was discontinued, the reaction by the owners, the people who invested time, money, and love in this thing, was a disaster. So you saw a lot of comments on the service formerly known as Twitter, like this, saying how profoundly unhappy this family was that they discontinued it, because the way they discontinued it was to have the little robot go have a dance of death. And it would dance back and forth and say, I'm going away now. I hope in the future someone will come back. This is not a great user experience. Not a great user experience. And so from this and other stories like this, I came up with this observation that poor UX blocks great AI. I had provably correct AI technology. Didn't matter. Did not matter. Jibo was a wonderful thing. When they turned it off, it was a disastrous experience. I could tell you more stories like that. Let's move forward. The other side effect is it can also break hearts. As we have increasingly affective computing that's increasingly embedded to our lives, this is going to be a problem. This social relationship to our AI systems will be a problem. Now, one of the things that I picked up from this time was it's really important for the system, the AI system, to have a user model. That is, the AI system knows about you, the individual, what you do, what you like, and so on, all this stuff. So that includes sensing, because one of the problems with the copier printer was it couldn't sense very much. It was effectively blind. So it had very poor sensing. And when it tried to interpret the user behavior, it couldn't make a good model of what the user was doing. So we would do things like try to track language use and create explicit models of user behavior, but it was just really tough. And I want to tell you now, in the context of current language models, a user model is not the same as a context window. A user model explicitly represents something that we know about the user. What we were talking about earlier, what's in their register, what the language is, and so on. So right after this thing happened, I went off and built the next extension to that, which was called the ID interpreter. And basically, this is now 88, represent 86. This is a representation of what the student knows about a particular system they were trying to teach them about. So we had an intelligent tutoring system that tracked what you knew and what didn't know. And this is sort of a map of that. This is the user model of what that person knows about this device. Now, this should look really familiar to you. It's a knowledge graph, but this is 88. And so this was, last year, the Khan Academy, the Khan Amigo, has exactly that same representation. Different domain, different knowledge, same representational structure, right? The difference between 1988 and 2024 is what? You do the math. Remember that. User models are imperfect and incomplete, and we have to remember that. What's missing? Well, the affective state of the person. Did their cat just die? Would that affect your interaction? Probably. What else is missing? What else do we not know? We don't know, for example, how sophisticated that user is. We don't know what language they use. There's a lot that's not in the user model. Now, I'm telling you all this to set you up for one of the key points of this talk, which is it's important for us to remember the frame that we live in, the research culture we all have. We all sort of swim in the sea that's invisible to us, or what constitutes valid research. And so we tell ourselves a lot of stories. We frame our work in ways that are positive and beneficial to us. And we try to convince our funders and our doctoral thesis committees that this is really valuable work. So let me tell you a story about the frame that we tell ourselves in research. So I've worked my entire career in industrial research, but I've always taught. I've taught for years, decades now, in universities, one place or another. So one of the stories we tell ourselves is that success is instant, or it's very fast. Let me give you a counterexample. Video conference. You use FaceTime, use Google Meeting, Zoom, whatever, right? The very first demo of video conferencing was when? 1960? How many of you were alive in 1960? Right, so you don't remember it. You don't remember it. But 1960 was the very first demo. There you see. It entered into the culture that same year in 2001, A Space Odyssey, the movie, right? At the time, from perspective of 1968, 2001 is the infinitely far future. From our perspective now, it's, whoa, that was 24 years ago, right? So that's 68. 1968 was also the mother of all demos. How many of you have seen this video? Okay, the rest of you, your homework assignment is to go watch it. It's on YouTube, type in mother of all demos. And you'll see Doug Engelbart as a young man using video conferencing built into his screen. He's also got a lot of other stuff, like the first mouse, first hypertext system. It goes on and on. It's really, really important to go see that. But that's 68. That's the first integrated computer video conference system. The next time you actually see video conferencing on a computer system is 1992 with See You, See Me. Some of you probably used that. It was pretty bad, truthfully, but it worked. It worked. And video conferencing enters into the marketplace in 2000, right? 25 years ago, it suddenly became a viable thing. This is an offering from Cisco. And it's 40 years, 4 decades after the first demo. This notion that we have instant successes is just wrong. And of course, this is what video conferencing really looks like now. A bunch of people gathered around a camera. I'm telling you this because one of my jobs, my first job, was working at Xerox PARC, working on AI systems, building the interfaces to them. And people have written books about how that didn't work. It was basically impossible to transfer technology out of PARC into the marketplace. So for example, Adobe was a couple of guys who left Xerox PARC to go found a company that would do PDF, printing, Acrobat, all that stuff, because Xerox, they didn't know what to do with it, right? There's a bunch of other technology. Ethernet's laser printing was invented at PARC. File servers was invented at PARC. Lots of stuff. So moving from concept to product is actually harder than you think. It's not enough to write a Chi paper. It's not enough. So here's another example. While I was at PARC, Alan Kay published a little paper about the Dynabook, which was basically what we think of now as a tablet computer. Now, Alan was a smart guy, but he still thought that tablet computers should have keyboards. This is now 1986. And of course, in 1986, 2001 also had it. So the notion of tablet computer is now into the culture. And a couple years later, I moved to Apple. And I was in the advanced technology group, and that was my office right there. And this was at the time in 1993 when the Newton was popular. Nobody probably remembers the Newton. It was a market failure, little handheld device you could do handwriting on. Not a great recognizer, not a great experience. It was just so a mess. So the next year, looking at that, I said, you know what we need to do is to build a full frame laptop with a whole integrated touch, integrated camera, integrated Wi-Fi, and this is the working prototype that my lab built. This is 94, called Vademecum. I took this to Steve Jobs, who was my boss at the time, and said, Steve, the future of computing is tablet computing. Look, behold. He said, that's the stupidest thing I've ever seen. Threw me out of his office. I thought, oh, all right. So when we all got laid off, all true stories, by the way. When we all got laid off, not because of this, other stuff, larger story. I took a group and we went up back to Xerox PARC, got some funding to do a startup called Uppercase. And we built, guess what? A working tablet computer. This is 1999. So we actually had several of these things out running and living in the wild in the world. It's great. But in that late December of 99, Xerox people who'd funded us said, what are we thinking? We don't do hardware. So we're going to basically sell you to Microsoft. And they sold the company to Microsoft. It became the tablet PC reference. So all the tablet PCs you see are based on the original model. Right. They don't tell you that, but I was there. So that was, they showed it at Comdex that year. And you can imagine my shock and surprise when 10 years later, Steve shows the iPad. All right, yes, sir. Good job. Now, the myth of instant success comes in many forms. You probably remember this, or at least you've seen the famous commercial, the 1984 commercial, because in 1984, the Mac comes out, instant success. You probably don't remember the year before the Lisa, which preceded the Macintosh, also by Apple. And I will tell you, it was a much better computer. It had a real operating system, for one thing. Multi-threaded, I mean, just on and on and on. Much better computer, but it lost in the marketplace. But it established the frame that such things could exist. It established the frame that personal computers could be a thing. That's PCs. Let me take you back a little bit farther. Back to 1956. This is the group of guys that got together. This is Oliver Selfridge, Nathaniel Rochester, Ray Solomanoff, Marvin Minsky, John McCarthy, Claude Shannon, people like that. This is where they invented the term artificial intelligence, the Dartmouth meeting. So what's so interesting to me about this is not that they came up with that term, but that none of them had beards. It's a separate story. John McCarthy was famous later in life for having a biblical prophet-length beard. It was really impressive. But that same year, Marvin Minsky was working on neural nets. Does that sound familiar? He's working on network technology. And in that same meeting, Ray Solomanoff was working on statistical word sequence prediction models in 1956. The predecessors to large language models were being worked on. So we think of LLMs as being something that just came out of the transformer movement a couple of years ago. People were working on this for 60 plus years. So it's not really instant success. Let me tell you another story. After that, after the sale of Uppercase and tablet technology to Microsoft, I went over to IBM and I ran a research lab there. And we did a bunch of stuff. But I want to tell you about one project in particular, which is this large display. Large display with a touch screen. Sounds completely blah, right? You would not get a Chi paper for this today, but I got a Chi paper back then, right? Because it was completely new at the time. It's obvious in retrospect, but it was, I took a big touch screen and put it on top of this display, right? And we then built a whole bunch of infrastructure that went around on top of that to allow social sharing, annotation, all that stuff. And that also did not work in the marketplace because I made the business case to IBM. We can own the large display market. How much money will we make? We'll make $100 million next year. Don't bother. It's literally what we were told. Don't bother. Not big enough for IBM. But we ended up transferring that technology to NASA. And this is the NASA Mars rover cockpit, where they're planning the motions of the Enterprise rover on Mars. And that's my big display in the background there that they're using. So personal success, market failure, right? On the other hand, you see these things everywhere now. They're in the subway, they're in the grocery store, they're absolutely everywhere. So I think we actually could have made a market out of it. But anyway, at the time, HCI is sort of finding itself, and user experience research is becoming one of those things that people are starting to want. And one of the big items of discussion is what counts as legitimate data. So I was working with eye tracking data back then, and a lot of the staff engineers and the research leads said, eye tracking data, what? That's not legitimate data. We can't infer anything from that. People will look anywhere. It's not true, but nevertheless, they would say things like that. Or, and I'm not making this up, people would tell me that survey data is inherently unreliable because people are just saying what they think. Why would you want to know that, right? Survey data is legitimately not acceptable as a data resource when making an argument about research. Same thing with A/B testing. I remember a time before A/B testing. Why would you do A/B testing? I'm a designer. I know what's right. I've literally seen people resign because we wanted to do A/B testing. And the designer said, if you don't trust me, I'm leaving. Walked out of the room. Gone. So all these things we now think of as obvious were not obvious at one point. The culture of research changes. What's acceptable data changes over time. But I have to tell you the eye tracking story. So this is 2004. I took an eye tracker to basically a Walt Disney World in Florida, and we had a bunch of people come in. We would sit them at a place like this and watch them as they would search for things. In fact, what we did a joint research project between IBM, Google, and Land's End, big clothing manufacturer and sell it online. And we said to people, here's a $50 gift certificate. I want you to buy something on the web. And we would watch what they do, what ads they would look at, what searches they would do, and so on. There's a couple of things to learn from this. One, putting an eye tracker in a big place like that where you have people from around the world is awesome. I had more diversity of people using my eye tracker than I've ever seen at the University of Ireland. That's a 70-year-old oil executive. He's never going to come in your lab here. Things like that. That's one thing. Diversity really matters. Second thing, if you're going to do any study of shopping behavior, any study that you run has to have real money involved. Because we did a lot of studies where we said, pretend I give you $20. Go ahead and buy a shirt. And people go, blue shirt, click, done. If I then say, here's $20, real $20, go buy a shirt, you're going to spend 15 minutes. Behavior is totally different. If you don't have real money involved in shopping studies, you're fake data. That data is worthless. Throw it out. So when I get a Chi paper that has a shopping study without real money involved, it's just reject. It's just instant reject because you're not actually watching actual behavior. So we watched this, we did a bunch of studies, a bunch of people watching as our eyes moved around on the page. And one of the things we discovered is that advanced searchers skip the first ad block. What? The advertisers went kind of crazy when we told them that. Like, what am I spending this money for? But novices don't. And there are more novices in the world than expert searchers. So that's good thing number one. And secondly, people would then come back. They would get to the bottom of the page. They would not go to page 2. They'd come back to the top and look at the ads. So ultimately, everybody saw the ads. Hey, great. But we now see why some people click on the ads many seconds after the other. So you have these two groups, this bimodal distribution. There are the 2-second clickers and there are the 30-second clickers. And there's nobody in between. And now we know why. Right? So we discovered something there. Interesting. So I spent the next 17 years at Google watching people search. And in one eye tracking study, this is a little video of the eye tracking study. I learned by listening to the person talk about the search they're doing and their thought process. So this guy was given the goal of find something to do Saturday night where you live. And I want you to listen to what he has to say. This is fascinating. Also, listen, you can hear Laura, my research assistant, not this Laura, different Laura, laughing nervously in the background, and you'll see why. So I stopped the video there because he modified the query to be adult activities Saturday night in San Francisco. I can't show that to you. But why is this funny? This is funny because obviously this guy doesn't know the internet is for porn. You like missed that lesson in school. And so something didn't connect. And that started me thinking, well, what do people really know about search? So I'm now at Google doing HCI for search. And one of the things I find out is that sometimes you go and watch people as they're searching for something, and they spend huge amounts of time. And what I quickly learned is that they don't know how to do things like this, Control F or Command F. Wait, everybody know this? I'm just checking. Everybody know Control F, right? So if I then say, give somebody a task and say, hey, look, I want you to find how long it took Beth Smith to run this race. This is the web page for 10K. You do Command F, find it, you're done, right? So when I did a study, I did one study where I had 85 people do the same task. Here's the distribution. You are over here, the far left, right? You do Control F, boom, you're done. There are a lot of people out here beyond 120 seconds. Trust me, there are people that took more than 300 seconds to find the answer, right? What are they doing? They're reading every single line. They're doing a visual search. Interesting. People who take more than 2 minutes to answer that question get the answer wrong a quarter of the time. Why? They don't know Control F. They don't know Command C or Command V. They don't know how to copy paste either. So I thought that was extraordinary. Really? So I did a study and I asked 2,200 US internet users if you know any way to find text on a page. And I've done this study probably 20 times. It's always the same. It doesn't matter how you ask the question. Do you use edit find, do you use whatever? It doesn't matter. 90% of people have never done text find on a page. 90% of people have never done this. So I asked a bunch of English teachers in the US. Half of the US, the teachers in elementary school, high school, don't know this. When I've given talks in computer science departments, every time I do this, I won't embarrass you. Every time I do this, I find somebody who raises their hand and says, what? Control F? Let me put it another way. People who've written books that you have in your courses, I have talked to them and they said, what's Control F? I don't know how you write a book without knowing Control F. So Analysis of Firefox users, 93% of Firefox users. I don't know why it's 3% difference, but 93% of Firefox users have never found text on the page. So this is interesting because I gave a talk at Google and said, hey, just so you know, 90% of people who use the web, use Google, don't know this. And so without asking me, an engineer said, oh, I know what to do about that. What we'll do is if somebody does a search like this, some random long string search like this, if there's an exact match on the page, we will highlight it. I wrote 0 bytes of this code. I'm so happy about that. It's one of those things where telling the right person at the right time, things get implemented. It's totally great. But still, we find this problem about how do people search? I mean, what do they know? So the guy asking about adult activities and Saturday night, he doesn't know that there's dragons in the internet, right? And so I was talking to a friend of mine who goes to Stanford basketball games all the time. I teach at Stanford, go to the game, and this is what happens at every single game. You've probably heard this song. Have you heard this song? Yes, you have, right? And so Bob says, how do I find that song? I want to get it on my phone. And I think SoundCloud or Shazam, no, those won't work because it's roughly 2,000 drunken screaming fans. Like, oh. How do you search for that? These only work on pre-recorded digitally copied material. So I said, give up. You're not going to find it. So he completely ignores me and goes to Google and types in O-O-O-R. Damn it. He has that song on his phone now. So what did I not understand? I didn't understand that roughly 1 million people before Bob had done that same query. And Google figured out when you type O-O-O-O, you mean this song, right? So it's a giant machine learning system in the sky. But people don't know. And in particular, I was too smart. I didn't know to do that. That's incredible. But yet we have failures. So here's a failure where Google pops up a reminder. This is my clever AI system saying, oh, by the way, Dan, you've got a reservation in a hotel in Davis for tomorrow. What Google didn't know is I called the hotel the day before and canceled that. In the classic AI terms, this is called the frame problem. How do you track what changes and what stays the same when you take actions in the world? And in this case, the AI system in the world does not know everything. The frame changed. Or another one here, this is my calendar system on my phone saying, it's time to leave now for Bodega Bay. Now, you see up there, it says leave now, 2 hours and 11 minutes. It is true that there is a city named Bodega Bay that's 2 hours and 11 minutes away from Mountain View, where my office is. But it's also the name of a conference room in the building. It's roughly 2 minutes from where I sit. So this is a type problem. In the computer science language, this is a type mismatch. Not the city, the conference room, but the calendar doesn't know any better. This is a fundamental problem with AI systems. Another fundamental problem with AI systems is that you can do things like this. So this was 2017. I go to Google Images. I say, hey, Google Images, show me my cat. Fantastic. Gives me a whole pile of pictures of my cat. That's great. So I did that again end of last year, gave me one picture. What? What happened? So did Google get done? Yes. This is called technically a regression, right? This kind of stuff happens all the time. And the fundamental problem for us is how do we design with a system that changes capabilities every single day? A new model gets pushed, and all of a sudden the ability to do that vibe coding you did last week is gone. Or it introduces new errors. Or it tells you something that's not true anymore. The UX analysis problem is how do we understand this when this stuff changes all the time? Another example. Google Maps again. So I'm trying to get from ETH in Zurich over to the Google office over near the Roca Alley. And what do I know about that path? I mean, it's easy to do, right? I want to go from this place to that place. What do I believe is true about that path? What's my mental model of this path? Do I believe it's safe at 3 a.m.? Do I believe it's the fastest path? Do I believe it's accessible to wheelchairs? What do I know? Answer, not a lot. I know it's a path that Google Maps has somehow computed to be optimum in some form, but I don't know what the definition of optimality is. And furthermore, I don't know how to modify the parameters. I don't know how to say the goal in a different way. Give me the most beautiful path. Give me the fastest path. Give me the least obstructed path. There's no way to do that, right? So lots of people out there saying AI is the death of UX design. They're completely wrong. The problem is different now. And yet, thinking about AI, does it matter? Does the frame of the way you think about the tool matters? So here's an example. You're sending an email to my friend Ira and say, see attached files. Google Mails pops up the thing and says, hey, looks like you forgot to attach a file. Is this AI? When does it matter? You want to know a secret? It's a regular expression. All it's doing is searching for the word attached. That's it. No AI involved, right? Does it matter? Does it matter when half the time companies say they need AI, they really need to select box? Does it matter? Well, I will argue it does matter because designing with AI is, you now need to know when you should know that it's AI and when it's not. Too often in our techno-hubristic world, I'll hear people say, hey, I know the problem. We're going to put machine learning on it. Trust me. That's not the solution. That is not the solution. It is not a magic acid that will dissolve all the world's problems. Instead, our fundamental challenge is how will AI address the user need in a uniquely valued way? How can we actually help in a way that's not through ordinary software? Here's an example. Here's a thought experiment for you. So imagine you build a smart agent that helps you out. So today is Bob's nephew's birthday. Bob's the AI agent sees that on the calendar and says, oh, Bob, you're too busy. I will write the email for you. Send it to your nephew. Say, happy birthday. Awesome. Nephew gets it. Joy. Let me tell you, there are PMs out there who are suggesting exactly this right now. Right? But how would Bob's nephew feel about that? Knowing that Bob had outsourced every shred of human emotion and caring to his agent. Second question, did Bob talk to his agent about how much he should spend on the gift? Probably not, because giving to my nephew is not the same as giving to my granddaughter. It's not the same as giving to my mom. What do I do? I want you to think about this, because one of the great successes of AI has been spell correction, right? You don't think about it as AI, but once upon a time, I used to hand out spell correction as an AI assignment. And so people would say, hey, correcting a word like that to can't with the apostrophe, awesome, you have won. And you might even think, spell correcting that to a different form by looking at my contact list and saying, oh, you mean John Boyd. Say, yeah, right. Smart AI, right? Now, suppose I write an email message. The population of Japan is 110 million. And my AI agent says, my spell correction agent says, oh, no. You mean the population of Japan is 125.1 million. See where I'm going with this? I'm giving you a slippery slope. Because the next email I write, World Trade Center was destroyed by terrorists flying planes into buildings. And instead of doing spell correction, it does concept correction. Kind of like the population of Japan, and it rewrites it like this. Who gets to correct your concepts? there's not enough cycles in your lifetime to go through and carefully align every single goal that your agent has between you and it. Especially because this half of the room is going to have different goals than that half. This quarter, et cetera, right? So how do we do this? Does your mental model of spell correction, does your frame include concept correction? So hallucination, as you know, is a huge problem. Of course, like I think everybody else, asked the version ChatGPT to do this. And of course, it gave me something that was 50% wrong. I wish that were true. I wish that were my biography, because it's very laudatory and like, yes, I was a professor at Waterloo. No, I never was, right? Or you probably saw this one where how to get cheese to stick to your pizza by adding glue. Might have seen that. But I thought, well, I'm really curious about hallucination, so I'll do an easy quantifiable test. From Wikipedia, I got a list of 4,000 composers, people who've written classical music or well-known music. And I said to ChatGPT, of this 4,900 classical composers and musicians, how many of them have a website dedicated to their music? And you can see the results over there. But ChatGPT said, there are 1,200 of those, and I checked. I can write the piece of code that actually goes and validates whether that URL is correct or not. And 49% of them are 404. Half of them are 404. I thought, whoa, it's not looking good. So I thought, well, Gemini will surely do a better job. Gemini says, oh, there are 4,700 of them. 95% of those are wrong. 95% of the answers are wrong. How far are you going to trust your AI system? So I want to bring up another point. One of the key things about people in AI systems is that there is an inherent social response that you have. I assume you're all humans, right? Go with me. You humans have this inherent social response to computation that smells and acts like people. So when you see this, you might see a face. When you see this, you might see a face. See where I'm going? When you see this, you might see a face. And this is such a common effect, it's called pareidolia. That's a psychological term for it. And so when you suddenly have text systems that create long, coherent, prosodic passages, you can't help but think it's alive. So this is a quote from Joe Weizenbaum's book, Computer Power and Human Wisdom. I don't know, Computer Power and Human Reason. And he points out this effect from his system, ELIZA. Now, the ELIZA effect is profound. Let me tell you, I taught AI at Santa Clara University for 10 years. And for the first 9 of those years, I would assign the ELIZA problem. Here, let me show you. Here's how ELIZA works. I would tell you how to do that. And then you would go away and come back the next week, and you would turn in 5 pages of your conversation with ELIZA, right? Except I never got 5 pages. I got 20 pages. I got 40 pages. I got 50 pages of people having long conversations with the ELIZA that they had built. And I learned way too much about my students. I learned about the girlfriend problems, right? So I stopped assigning that because even though I would tell them about this effect, it wouldn't matter. It wouldn't matter. And so a couple years later, Cliff Nass did a bunch of studies about this and came up with this comment here, which I love. When debriefed, the subjects in his study insisted that they would never respond socially to computers and vehemently denied the specific behaviors they had, in fact, exhibited in the experiments, including over-trusting a model that sounds plausible. How much do you trust your chatbot? Well, Air Canada has had to pay out a lot of money because its chatbot overpromised all kinds of deals that were not true. And there's another headline like this every single day, where some company or worse, some lawyer has filed a brief with the court saying, oh yeah, we're going to say this, and they get caught out because they're all hallucinated every single day. So yeah, I've seen the dashboards. Yeah, rate of hallucination is getting better. I don't believe it. I can cause a hallucination with the most banal of queries every single day. So this popped up in my feed about a guy who imported a PDF file in Chinese and asked ChatGPT to translate it. And it translated it, but he thought it was a little funny, so he asked a Chinese-speaking colleague, what's the story here? And the document and the translation have zero to do with each other. When he asked ChatGPT what the story was, it says, oh, when you first uploaded the document, it contained no visible extractable text. So when I saw that, instead of telling you this is empty, I tried to be helpful and I made it up. That's the definition of a hallucination, right? So this is from last week's Anthropic's open system card. We also discovered training episodes where we accidentally posed the model an impossible task, and the model, despite determining its reasoning trace that the task was impossible, did not disclose this discovery and instead produced a superficially reasonable solution attempt. That's Anthropic's own internal report, saying that they can't even detect when a hallucination is happening. So there's a famous example of this from a little while ago. Somebody asked how many presidents, US presidents, went to the University of Wisconsin-Madison, and it's all wrong. It's completely wrong. This is such a, we call this hallucination. I think it's actually cybernetic mansplaining. Much better term, right? Much better term. I can make the slides available if you're ready to do this. I'm totally happy. And this becomes problematic for a lot of reasons, not the least of which, if your lawyer does this, you're in trouble. If your car company sells you a car, which happened at a dealership near me, where they sold a $100,000 car for $1. And the court said, your chatbot said it was $1, you have to do it. And so they lost $100,000. But it becomes more important when you are dealing with things like this. There are mushrooms in the world, some of which will kill you. There are apps in the world that will identify any mushroom with just a click. And the thing is astonishing, 4.9 star reviews. 4.9 stars out of how many reviews? 5 million downloaded, right? 100,000 reviews. This is the definition of survivor bias. Dead people leave no reviews. So I think what this tells us is that cybernetic mansplainers really need epistemic humility. They need to admit when they're making stuff up, because as you saw, it often knows it could say something or it could reveal the guardrail. So I've spent a lot of my career studying how people search. And so that's, I've done studies and I've done all kinds of stuff. I wrote the book here, which is basically, Laura mentioned this at the very beginning, is basically a series of stories trying to teach people how to be better searchers, how to use this immense computer we made the size of a planet, and yet people use like 1% of it. Because the mental model a lot of people have of Google is that it's everything 24/7. People will tell that to you. Everything's on there. And so if you ask people to draw their mental model, computer scientists, probably everybody in this room would draw something like this. There's index, there's a crawler, there's a web, blah, blah, blah. But you want to know what most people do? Yeah, they draw things like this. That says, Google is several overlapping concentric circles of nonlinear Boolean targets. I have no idea what that is. No idea. And furthermore, a third of all the drawings I have, and I have over 1,000 at this point, a third of them say magic somewhere on it. That means I've given up. I have no idea what's going on. It's pure magic. Magic means I have no causal explanation. As a mental model, this is not great. So I've been teaching people how to search. And I'm going to show you just a little fragment of a video we made. This is the game we made. We set out to make users more savvy and creative searchers by demonstrating power search. We came up with this mosaic, a data shifter puzzle that can be solved using clever search skills. We wanted to educate without lecturing, so we had to come up with some fun questions that can answer to the quick search.
for not just one search or one kind of search, but for routine. We want to teach users about all the different searches they can do. And that's the key part.
So anyway, it goes on and on. We did this, and it was run for 1 quarter, and we finally turned it off 4 years later. So kind of a success. And I got engaged at this point in teaching people how to search. That was one method. I also did a massive open online course where we had, I don't know, a couple, like 5 million people or something go through the course at a 35% completion rate, which is really great. I added it up the other day, and I've been on somebody's little screen talking to them for 450 years. I don't know about other faculty, but I feel like I've exceeded my goals. And so we did this really interesting analysis where this is the period of the course here. So people come in basically testing at this, performing at this level, basically 0.4. And they go through the course, and the people in red are the people who did not complete. So they come out of the course exactly the same as they were in those courses. People in the black line who exit the course, 2 things. Faculty, pay attention. Pay attention. Once the course stops, they forget half of what they knew. They should not stop tracking. Right? But the cool thing is, for this course, we tracked them for a couple of weeks afterwards, and they were performing twice as good as when they came in. Twice as good. You can make a difference, and you should be evaluating the effect of your interventions, not just at the last day, because people will test well. Ask them 2 weeks later. Do they still remember? So at the same time, I was doing some work on visualizations. I did a bunch of work over the years, but I'm going to show you one result, sort of interesting. So there are a million bespoke visualizations, right? Including things like this. Interesting thing to me was I was watching people at Google, the executives, the data analysts, the PMs, and watching, I thought, you know, I never see that kind of chart in reality. So I wrote this paper because one of the things I found in an interview was somebody said, the last thing you ever want to see is an executive's eyes glaze over when you're trying to explain your damn visualization to them. You've got 20 seconds. If you can't get it done in 20 seconds, next slide. So I did a little study. I asked, and I pulled a whole bunch of presentation files down and looked, what do people actually use? Any guesses?
Sure.
Yes. Here's the answer. Line graph, histogram, table, right? And here's the other thing. That's 85% of all charts on over 2,000 different presentations and roughly 200 different whiteboards. You see where I'm going with this, right? If you can't explain it in 20 seconds, it's tough. You will lose an audience. So what makes an audience as a visualization success? It's not just monetary reward. And I'll tell you a story about a student of mine. Heidi built this really great visualization tool to look at longitudinal data, Java application. Awesome. She got a PhD for this. She did user studies, et cetera, et cetera, et cetera. And we implemented it, got people to use it. Analysts loved it. And then what happened? Want to know? Great. And it's like, what happened? We built this great tool. Nobody's using it. It didn't even show up on my chart. So Heidi then came back, rewrote the whole thing in JS, and made it easily launchable, easily part of the dashboard, took out half of the functionality. All of a sudden, it becomes a constant daily use tool. So adoption depends not on just solving a real problem, having retention, but also being simple enough to use. This, I think, speaks to where we're going with HAI. The future. So we now have all this generative media. We have this incredible set of things. Should we be teaching courses in prompt engineering, or should we be teaching robo-psychology? Because you probably read a bunch of those prompt tools. Be nice to your large language model. Does that make a difference? Maybe you should ask in a really imploring tone to write something for you. So we have these new interaction models I think are coming up. And so I think, in fact, UX design and research is really going somewhere new and interesting. The doomsayers, I think, are completely wrong. There's new stuff happening all the time with, for example, these tools that have new capabilities, new interaction models. And we're having what I would think of as AI creep. Remember concept correction? That's creeping in. That's creeping in. And you're getting, for example, automatic visualizations. I can't do anything anymore without some agent saying, can I rewrite that for you? I could make it into a tagline. Leave me alone. Right? Just leave me alone. So what we're getting is not just interventions to help you rewrite and do things, but potentially political suggestions or correcting data errors for you in ways that you may or may not approve of, right? Or my very favorite one, yeah, take it that way. What's the future? I put up this picture of Keira Knightley as done by Botticelli because AI can now extract styles as an object. I can say, take this object and apply the Botticelli style. Botticelli is kind of computer. Keira Knightley, not so much. Right? So who gets to say copyright here? Or there's a notion of a Bach faucet. I turn the faucet on, I get infinite amounts of pseudo Bach. Right? Or my AI class at Stanford has a theme song. And this is it. It's called Artificial Hearts. I asked Suno, I gave prompt to Suno and said, hey, Peter Norvig and I co-teach this class at Stanford. Can you write an emo rock song for me? And we've got this. Does your class have a theme song? You see the deeper point here is there's a lot of stuff coming on and we have no idea what to do with it, really. Legally, regulatory, all that stuff. The problem is that tech turns very, very quickly. The legal processes go like this, right? I don't know how it's going to be transcribed, but you get the idea. Okay. Regulation does not keep up. And so what can we do as HCI people, as UX research people, UX design people? We need to shift from AI first, which is what every company is saying right now. We are an AI first company. We're going to lay off 20% of our staff and replace them with AI. So far, that has not worked that well, just so you know, right? We also have a third order problem, which is all of a sudden AI is eating the world. So this is an AI overview from, I guess this is Perplexity. I said, give me a recipe for chicken parmesan. And yes, it does give me the link to the top. Let me tell you, very few people click through that link to the recipe site. So if you're the recipe site owner, what do? Boom, 20% profit click-throughs. Your revenue goes to hell in the handbasket. We have to think about how AI affects not just you, but also the ecosystem. This is downtown Los Gatos, near where I live. That string of cars is all going to the beach. Why are they there? Because Google Maps has determined that the freeway has too many cars in it, and so it's routing them through this little, you call it, quiet town. And so this really pisses off the people that live there. What do? I'll tell you. What's his name? Simon Veckert has got a little red wagon, and he put 99 Android phones, and he pulls it down the street. Why? Because he's simulating 99 cars going down the street, which causes Google Maps to reroute back onto the freeway. Right? So we're suddenly having spam and anti-spam, AI and anti-AI happening all at the same time. Last example. Another AI problem is what I call ensemble failures. So if everybody in Silicon Valley or everybody in Reach a Synpro has an AI thermostat, they all pull power at exactly 6 a.m. because they're all synchronized. Your old classic thermostat didn't do that. It was all staggered because of the stochastic effects of time and temperature. All of a sudden, now we've got this fleet of furnaces or air conditioning all going on simultaneously. which caused huge power spike problems for the company. So we need to design not just for society, but design for the entire ecosystem. So this stuff is important. It's important that we get the user experience design, these things critical. It's the kind of thing where it has to be not just added on at the end, but it has to be built in from right from the very beginning. And when we stare down the river of time, does it matter what you call it? So the story is that what really happened is that I was on this body of water with my friend Doug Einer. We were talking about it. And where are we? What's going on? He said, well, there used to be dolphins here. And at that moment, a dolphin leaped out of the water. I thought, this is a setup, isn't it? Right. But I realize now we're in a fjord. That's not a river in North America. You now know a lot about that body of water, what temperature it is, how salty it is, the kind of fish in it. So all this stuff, right? We tell ourselves these stories that we can build technology, people will come. Not true. Not true. Research does not immediately convert into product. And the names and framing of concepts, especially in AI and the way people use it, is deeply important. Thank you.